Hello, my name is Matt, and today we'll be playing Triangles by Riffclown. This is a puzzle that is about 470 days old, so it has a lot of solvers, but I have not played it yet. I'm excited to. And there are a lot of triangles going around in this triangle puzzle. So let's figure out the rules. What are the rules? Normal Sudoku rules apply. This is a Sudoku. Digits on a wide purple Renban line form a set of consecutive digits in any order. Digits on a thin blue region sum line have the same total for each region the line enters. Different lines may have different totals, and then adjacent digits on a green German whisper line must differ by at least 5. 1,830 solvers is the number, and we're about 36 seconds in. So let's figure out how to play this puzzle. Triangles. How are we going to do this? Well, I notice that there's this big triangle diagonal. I notice that there are these lines, these green... I wonder how we're going to do this. I'm not quite sure where to start. I guess these are region sum lines, right? So what that would mean is that these two squares need to be equal, and they need to be the sum of these two. In fact, these two squares need to be equal. These three are going to add to a number that's going to go right here. That's interesting. I guess we're going to get... I'm noticing now that the triangles intersect at these points. So this point is part of both triangles. And so is this point and this point and this point. We have this long diagonal. Then we have a 7. But I've done a lot of talking. We should figure out what we're going to do with the solving. I'm not quite sure yet. So first things first. Is there a first things first? I still don't see anything. We're 2 minutes in. I know some things about some of these lines. So the green German whisper lines, they need to, first things first, they can't contain a 5 because the digits need to differ by at least 5 along the line. So if there was a 5 here, there would be nothing that could go here. In fact, they're circular, so I wonder how that affects things. Because of the fact that they're triangles, can they contain a 4 or a 9? So first things first, why can't a 5 go here? It's because the adjacent digits on the line need to be separated by at least 5. So we would either have a 0 or a 10, and that is not allowed in Sudoku. So you can't be a 5, but can you be a 4? If you were a 4, to differ by 5, we would need a 9 here. We would also need a 9 here, so that doesn't work. And I think by the same logic, that means that this can't be a 6. So what we know is that 4, 5, and 6 can't go on the green triangles. And that means in this row, 4, 5, and 6 can't go here, here, or here, here. You guys, you need to be the numbers 4, 5, and 6 in some order. But we don't know what order yet. We know that these form consecutive digits. Is that right? Is that what the purple lines are? The Renban lines form a set of consecutive digits in any order. And they're of length 4. So I guess we would have problems if the 5 is not on the line. Isn't that right? Because if a 5 was here, we would have 4 and 6. We would need consecutive digits, which would mean a 5 would need to be on here someplace. So what that means is that the 5 can't go here. The 5 needs to be on this line. In fact, it's definitely going to be like 5, 6, 7, or 8, or 5, 4, 3, 2, because we know that one of those numbers, so a 6, if for 10 to 6 didn't go on the line, that would mean we need to start at 5 and count down. So what do we know? You can't be a 5. That's certainly true. But then also, I guess this can't contain 9 or 1. We're either going to have 5, 4, 3, 2, which doesn't have a 1 on the line, or we're going to have 5, 6, 7, 8, which doesn't have a 9 on the line. That means that there's either going to be a 1 and a 9 up here, or a 1 and a 9 down here. Or rather, the 1s and 9s can only go in these squares. But I bet we would have problems putting the 9 up here, wouldn't we? Because the sum of these two needs to be equal to these two. I guess the 9 can't go up here. You can't be a 9. A 9 needs to go down here. We don't know about the 1. But it feels right that a 1 would go on this line. Maybe this is 1 and 3, and then these two are both 4 or something like that. But I feel like we've learned a little bit about the grid. I'm happy about that. What else? These are consecutive. They split into a couple of regions. These are region sum lines. It's interesting that the region, there's two, at least two, that have, we know that these two digits are the same because they're in different regions but on the same line, and there's only one square in their region that's connected on the same line. The same is true down here. So we know that, but we've made a little bit of progress down here with the 4, 5, and 6, I think. We know that a 9 definitely goes down here someplace. We'll have to figure out how to use that. I guess we now know that everywhere we see a green triangle, we can't have a 4, 5, or 6 on that line. But we also can't have a 7 on this line. So what does this mean? So around here, we're definitely going to have the numbers 4, 5, and 6. Where do the 4, 5, and 6 go in this region? They definitely do not touch this green line. But now we have this point. In order to make a 4, we would need these to be 1 and 3. That seems possible. In order to make 5, we could have a 2 and a 3 here. The 1 could go down here, and then we would do some things. So that's allowed. In order to have 6, we could either have a 2 and a 4, which is, I guess, allowed, or we could have a 1 and a 5, which is, I guess, also allowed. I wonder what the interplay is between these, because now this is going to be consecutive, but we know where the 4, 5, and 6 go in this region. I wish we could shove one extra digit out here. I wonder what that digit would be. 4, 5, and 6 can't go on this line, neither can 7. So what does that mean? We talked about the fact that a 5 can't go on the line. We've talked about the fact that a 4 and 6 can't go on the line. But what we also know is that the digits on the line are going to hop from high numbers to low numbers. If I put a 2 here, then I would need to put a high number, something above 5, on the other side of the line. It could be a 7, can't be a 7, but it could be an 8 or a 9. What this means is that this line definitely has 2 low digits and 2 high digits on it. And if the 7 is here, that takes away one of our high digits. We can't have a 6. Definitely an 8 and a 9 go on this line someplace. And they're going to be separated by 1. So maybe either this is an 8 and a 9 or this is an 8 and a 9. But we definitely know that an 8 and a 9 go on this line. I'm kind of worried about putting down too much notation. I'm a little worried about making it difficult to read for myself because we don't know anything about the other digits. But if there's 2 high numbers up here, then there's going to be 2 low numbers. So the low numbers we can draw from are 1, 2, and 3. That means the extra digit that is going to go in one of these cells is definitely going to be a 1, a 2, or a 3. Interesting. I guess because of the fact that in this puzzle we only see green lines that kind of appear in these triangles, then the middle numbers are always going to be 4, 5, and 6. Anywhere we have a green line, we can't have a 4, 5, or 6 on it. And what that means is that, well, we sort of knew this already, but in this row, we're going to need the numbers 1, 2, 3, 7, 8, and 9 are going to be around this. That's 3 low numbers and 3 high numbers. So now I could maybe start to isolate where the low and high numbers go. Maybe we don't know what is what. I don't want to remove these yet, but like, for example, call this square yellow. Excuse me. Yellow is going to be either a low number or a high number. That would mean this needs to be the opposite. Let's not use pink. Pink is going to be too hard to see. Let's use brown. Sure. All right, so we've got yellow, then brown. This needs to be the same as this, and this needs to be the same as that. But we know that in this row there's going to be 3 low numbers and 3 high numbers. That would mean that these now need to be brown, and these two need to be yellow. but we don't know what this fully means yet. I feel like I really like this puzzle because I'm not sure where to start. I feel like I've learned a lot of isolated things. I'm just having difficulty connecting them all. That's a sign of a good puzzle. All right, 7 is definitely a high number. It's going to go here. We're going to need another low number. It's going to go in one of these. One of these is going to be a low number, I think. Okay, so I guess in this puzzle, there are going to be 3 low numbers. That's 1, 2, and 3, and 3 high numbers. What that means is that these 2 can't be yellow. They need to be brown. Whatever brown is, whether it's the low numbers or high numbers, if these 2 had to be yellow, then it would conflict with these. So we know something. And then maybe we could work here. This isn't allowed to be a high number, I don't think. If this was a 6, I guess if this was a 6, then we could have 1 and 2, and this would be a 9. So maybe this... No, it can't be a 6, excuse me. It can't be a 6. Okay, so the yellows need to be the low numbers. That's exactly right. Because if the yellows were going to be high numbers, then we would have a contradiction around this region sum line. So what does that mean? That means that these 2 are definitely 8 and 9. Hooray, we've learned something. You guys, definitely 8 and 9. And that's going to be fun to play with, I guess, because of... I guess now we know that you guys can only be 1, 2, or 3. I don't know why that would make it particularly fun to play with. But now you guys, all of the yellows, you can only be 1, 2, or 3. And all of the browns, you can only be 7, 8, or 9. We're going to run into problems if this is a 7. I guess we won't. We would need 1 and 2, and then we would need 3, and then 8 and 9, and then maybe this could be something else. But what's going on? There's a 7 here. That means you 2 cannot be 7. You 2 can only be 8 or 9. Interesting. You are a region sum line. We know where 2 of these go. We know potentially where the 3 goes and the 2 goes, but not the 1. We know where 2 of these 3 low numbers. I'm going to call the low numbers 1, 2, and 3. I'll call the high numbers 7, 8, and 9, and I might use the middle numbers for 4, 5, and 6. We know these are middle numbers. Maybe I should give them a color. Also, there is another brown, so me calling this brown was maybe a mistake, but we have to figure out where to go from here. You are pretty small. I feel like that's going to force you guys to be small. 5 could be 4 and 1. I guess, hold on, I guess 5 can't be 4 and 1 because of the 4 down here. 5 would force this to be 2 and 3, which are, again, low numbers. And if this was 6, then we can't have... Can you be 6? If you were a 6 here, then we can't have 3 and 3. But we also can't have 2 and 5 because there's a 5 down here. And we also can't, or we can't have 2 and 4. We also can't have 1 and 5. So you're not allowed to be a 6 anymore. And if you are not allowed to be a 6, then you are 4 and 5. 4 and 5 is achievable with 1 and 3. 4 and 5 is achievable with 1 and 3. Excuse me. 1 and 3 gives us 4. To get 5, we would need 2 and 3. So it's either 1 and 3 or 2 and 3. That means the 3 definitely goes here. There's definitely a 3 up here. And if there's definitely a 3 up here, then here, you're not allowed to contain a 3. And that means that you need to count up. So you're not actually allowed to contain a 4. You must be our 4. Now, this must be 5 and 6. And then we would have 5, 6, 7, 8. This can't be a 7, so you need to be a 7, and now you need to be an 8. And we've learned a lot. That was cool. I liked that. Now, what number are we missing? If you guys are definitely 1 and 3... Wait a second. Sorry. You're not definitely 1 and 3. You can be a 2 and a 3 or a 1 and a 3. A 2 is also allowed up here. So we're looking to place the numbers 1, 3, 2, and 9. And a 9 definitely goes down here someplace. I guess if a 9 definitely goes here in this row, and a 9 definitely goes here in this row, that means the 9 must definitely go up here in this row. But I don't know if that tells us everything. But still, if you are definitely an 8 and a 9, then you must definitely be a 7. And if you're definitely a 7, then the 3, in order to have something that is difference by at least 5, you can't be a 3 anymore. Neither of you are allowed to be 3s. And if neither of you are allowed to be 3, then you are 1 and 2. What that means is that you are definitely a 3, and now you are not allowed to be a 3. Good. Probably messing up the notation, but maybe you've been able to follow along with my words. Okay, if you're definitely a 4 or 5, then you need to be a 4 or 5 because this is a region sum line. What's the problem is that you are not allowed to be a 4. That means you are not allowed to be a 4. You must be 5, and now so must you. And if you are 5, then you two are not 1 and 3. My backspace isn't working. If you guys are 5, then you can't be 1 and 3. What you must be is 2 and 3. And that means you guys must be, again, I guess maybe I'm just on the wrong thing. I don't know why my backspace isn't working, but you guys are not allowed to be 1 and 9 anymore. What is going on with my keyboard? How about I do it up here? Does this work? I guess that works. But if you are 2 and 3, then you need to be 1 and 9. You guys down here, definitely 1 and 9. Now the 5 is not allowed to go here or here. What that means is that you are definitely 4 and 6. I don't know if that's the case. Let me get back to that in a second. A 4 and a 6 must go here, here, or here, which would make sense if this has to be an 8 or a 9. If this is an 8, then we could have 8, 9, 7, 6. A 6 must go on this line someplace. But is a 4 able to go on this line? 8, 7, 6, 5. A 4 isn't allowed to go on this line. So you're no longer allowed to be a 4. That 4 needs to go down here. What is the other mystery number that we are missing? It's a 1 or a 2. A 1 or a 2 must go someplace, but you must be an 8 or a 9. I don't think that's going to work. I think you need to be a 6. And now the numbers that are allowed down here are going to be 4 and 1 and 2. 4 and 1 and 2, but you can't be a 1, so I guess the 1 needs to come out down here. And now in order to have a 1 in this region, it needs to go here. So I am comfortable with all of that. What needs to go over here? We know where the 2 and the 4 go. We know where the 1 and the 9 go. We know where the 7 and the 8 go. I think what that means is that remaining we have 6, 5, and 3. You guys are definitely going to be 6, 5, and 3. We know where the 1 and the 2 go. We're missing a 4. A 4 needs to go in this region, but can a 4 go on the line? 8, 7, 6, 5. A 4 can't go on the line. We established that. You need to be our 4. You must be a 4. I like the way these triangles are working. We've made a lot of progress down here, I feel like. Okay. Again, 9, 8, 7, 6. So this could be 8 and 7. Can it be 8 and 7? I think that's allowed. You're not allowed to be a 7, but the 7 could go up here. And that might actually work pretty well with this region sum line. But you're allowed to be a 7, which means you're sort of allowed to be 8 and 7. I guess the numbers that we are missing are 8 and 9. So an 8 and 9 can't go here, can't go here. It can go here, but we're going to need another one. You guys need to be 8 and 9. So what this means is the numbers are 8, or 9, 8. We're missing a 7. That 7 needs to go here, and then 6. So that's how that is going to look. But now with the 7, because of the region sum line, these numbers need to add to 7. I think the only way of adding to 7 is 1 plus 2 plus 4. That means that a 3 can't go on this line here. We would have 1, 2, and 4. I guess we're going to learn in a second that a 1 can't go there, but let's just put them all in, and then let's deal with it later. So this is going to be 1, 2, and 4, except you're not allowed to be a 1. This is definitely where the 1, 2, and 4 go. And now that means that this is not allowed to be a 1 or a 2. You must be a 3. And that works because of the 8 and 9. So we have learned some things. The Renban lines plus the high numbers, which is sort of what we're getting with them. At least these ones are going to be high numbers. At least these ones are going to be kind of high numbers. They work interestingly. All right, we know where the 1, 2, and 4 go. We know where the 8 and 9 goes, and we know where the 3 goes. So what's missing for this region? This region up here. Well, we're not missing 1, 2, 3, 4. We are missing a 5. We're missing a 5, but that 5 can't go here or here. What that means is that that 5 needs to go up here. What are the other things that we're missing? 1, 2, 3, 4, 5, 6, and 7 are what are missing up here. You guys must be the number 6 and 7, except you're not allowed to be a 7. You need to be a 6, and now you need to be a 7. So now we're going to have a loop up here that we're going to need to figure out what to deal with. But I feel pretty good about that. This I feel pretty good about. This I feel pretty good about. The smallest number that this could possibly be is 6, because the smallest sum of 3 digits on the keypad is 6. But it can't be 7. I suppose it could be 8 or it could be 9. But there's going to be some funkiness dealing with that here in a second. I guess if this is a 5, then this must be a 5 by region sum line. And now you are not allowed to be a 5. And now we need some numbers for here. Now we can start making 5 in other ways. Should I remove the colors? Colors might just get in the way. We can start making 5 in other ways. So we're going to need low numbers, but we could use a 1, 2, 3, or 4. I think that is all fine and good and reasonable. What that would mean is that the maximum digit for this is 4. So 4, 5, 6, 7. I guess we can't have an 8 or a 9 on this triangle anywhere. But we also can't have an 8 and a 9 on this region sum line. That means the 8-9 pair, wherever it goes, must be up here. You guys, one of you is going to be an 8, one of you is going to be a 9. So where is the 6 going to go? I wonder if we can now force the 6 to go out here, because I don't think a 6 can go on this line. A 6 can't go on the region sum line. Can't go here. If a 6 was down here somewhere, then we would need to count down, because we can't use 7. So we would have 6, 5, 4, 3, something like that. I guess in this instance we could have a 4 or a 3 here, but we could have a 6 on this line. That seems possible. Interesting. But I feel like we made a lot of progress. I feel like we've made a lot of progress. But what to do with it? 2, 3, 1, 9. I guess maybe I can make this a little easier on myself. You guys have to be 1 and 9. You guys have to be 2 and 4. You need to be 3, 5, and 6. 1 and 2, 8 and 9. And then there's another 8 and 9 thing floating around up there. We're 23 minutes into the puzzle. Wow, time flies. This has been fun, though. I wonder how long it's going to take. Let's see. This is interesting. It needs to be at least 6 because it's the sum of 3 numbers, but it can't be 6 because of this 6. It also can't be 7 because of this 7. So you're only allowed to be 8 or 9. Those are the only numbers that can go here. And if you're only allowed to be 8 and 9, I wonder how we're going to make it. We can't put a 5 anywhere on this line, because a 5 can't go on the green. It also can't go on the blue. So a 5 isn't allowed to go on the line? How would I make 9 with 3 numbers? I would use 2, 3, and 4. And I think that's allowed. I could use 1, 3, and 4 to make 8. But I think those are the only 2 options if we don't use a 5. I guess I could have 1, 2, and 6. I didn't think about it, but that's allowed too. I wonder if I should be continuing with these colors and then maybe we would see some patterns emerge. The colors are really only going to be helpful with the green lines where you have these, like, I always use the word oscillating, although I don't know if it's the right word, like oscillating pattern, green, or yellow, brown, yellow, brown. Still, the maximum number that can go on this line now is 6. And that means that these definitely can't contain any high numbers. None of them can contain high numbers. You're not allowed to have a 7, 8, or 9. That means that this needs to be a low number. So we can bring back the colors and say that these are both low numbers and these are both high numbers. Our low numbers are 1, 2, and 3. Our high numbers are 7, 8, and 9. You're definitely a 1, 2, and 1, 2, or 3. I feel like there should be something I can do up here. Because we need consecutive numbers. We need 4 consecutive numbers. We're not allowed to use a 7. So what needs to go on this line? 6, 5, 4, 3. If 6 was the maximum digit, we could get up to 3. If 5 was the maximum digit, what would we get up to? 5 was the maximum digit, then we'd have 5, 4, 3, 2. Something like that. But yeah, all right. Be nice if there were more information in the columns. There isn't a lot of information in the columns at this moment. Like, I don't really know what I'm supposed to do with this 4 and this 5. I guess I can now say that a 4 and a 5 have to go out here someplace. Definitely a 4 and 5 go out here. But are you allowed to be a 4 or 5? That would be interesting. I guess we could have 5, 1, and 2. We would get 8. Oh, wait a second. Hold on a second. A 5 can't go here, and a 5 can't go here. That means there's only one spot left for the 5 in this region. It's there. And now if you're a 5, you need to be a 6 so that you can be a 5. And now I feel like we know where many of our 5s go. We're just missing a couple of them. In this region, we're going to need a 5 in one of these 2 cells. Definitely a 5 goes here somewhere. But we can't have a 7. That means the maximum on this is 6. We're going to have 5, 4, and 3. 4 and 3 are definitely going to appear on the line. But that 4, can it go up here? 4 and 1? I guess that would be allowed. Interesting. If this is definitely 8 and 9, and this is definitely 7, then this, you are definitely 6. That's true. And now in this region, we're going to need a 6. That 6 is going to need to go here. And now if this is a 6, then the smallest we could possibly do is 1 and 2. And that would give us 9. So you need to be a 9, and now you need to be an 8, and now you need to be a 9. And now you're no longer allowed to be an 8, but that doesn't tell us anything yet. Anyway, if you're a 9, you guys need to be 1 and 2. Let's just delete you and start over. 1 and 2. One and 2 definitely go here. You need to be an 8, and now you need to be a 9. I think all this checks out. 4, 5, 6. If the 1 and 2 definitely go here, then you can't be a 1 or a 2. That took me a little bit to see, but you can't be a 1 or a 2. The same is true with you, and the same is true with you. You need to be a 9, you need to be a 3, you need to be a 1, and you need to be a 2. And now in this column, we're missing some numbers. What are those numbers? Well, we know where the 1 and 2, 3, 4, 5, 6 go. What we're missing is 7 and 8. And 7 and 8 must go up here and here. Is there anything preventing either of those? I don't think that's the case. You guys must be 7 or 8. Definitely. And now we've got 3 cells with 3 numbers in them. So there must be a missing digit. That digit is 4. That 4 goes here. But we're going to use a big 4. You are a 4. And now what? We need a 4 in this region? I don't know about that. I mean, it's true, but I don't know about it. You got to be a 1 or a 2, 2 and 4. Okay. In this column, what are we missing? Well, we're missing a 1. That 1 must go up here somewhere. One of you two is definitely a 1. We're also missing a 2 and a 4. So I guess the other numbers that could go up here are 2 and a 4, and they're going to pair with this. In this column, we are also missing a 2 and a 4. But we're also missing a 5 and a 6. So 5, 6, 2, and 4? Except a 6 can't go down here. I'm just going to... This is all going to be very muddy pretty soon if I keep adding these small pencil marks. I guess if you are a 3, then you two can't be 7. That 7 needs to go up here. Now you're a 7. This means you need to be an 8. And now you two need to be 8 and 9. We've got a 1 here. You guys are definitely 1 and 2. I feel good about that. You are 8 and 9. We've got a 6 there. So what is missing in this column? We're going to need a 7, which can't go in this row. Yeah, we're also missing a 3 and a 4. The 3 can't go in this row. Okay, let's put those down. 3, 4, 7. A 7 also can't go here. Huh. So you're our 7. And now 3 and 4 go on the outside, so that seems fine. How about you? What are we missing over here? We're missing a 1, a 2, and a 9. 1, 2, and 9. That's what goes here. You can't be a 9. You need to be 1 and 2. Again with the pencil marks. I'm just going to screw myself up later with those. 32 minutes into the puzzle. This is a very long solve. It's not that long. But let's keep moving. I wish I knew some reason why this couldn't be a 9. I wish I could force this to be an 8 and a 9, and then it would take this out, and it would add that, and everything would be happy, but it's not like that. We need a 7 up here. We need a 5 up here. A 5 needs to go in this region someplace. It can't go in this row, can't go in this row, and it can't go in this column. So you must be our 5. And now we're probably pretty close to all of the 5s. I guess there's going to be a 5 down here, and there's going to be a 5 here. But that's where our 5s go. What else are we missing in this column? Although I think we've done it more than once. We're missing a 1. No, we're not. We're missing a 2, a 4, and a 6. 6 can't go here. 6 can't go here. You must be our 6. And now you can only be a 2 or a 4. But you also can't be a 4. You must be a 2. And now you must be a 4. And now you must be 1 and 4. And by the way, you must be 1. If you are 1, then you need to be 2. I should do this with a keyboard. You're a 3, you're a 4. You two are 1, 2. We should have been able to figure that one out earlier. I might have just been hanging there. 1, 2, 1, 4, 1, 2, 9, 8, and 9. This is all good. I think we've done all of these triangles correct until the pencil marks. Now we just have to figure out what to do up here. So we know where the 1 and the 2 go in this row. We also know where the 3 goes. What's missing in this row is a 4, 5, and 6. You guys must be the numbers 4, 5, and 6. 4, 5, and 6. Except a 4 can't go here, which we knew, and a 5 can't go here, which we also knew. But if you're a 4, 5, and 6, then on the other side of that we need a 3. And if you're a 3, then you must be a 2 so that we can add to 5, and we've completed another one of these triangles. 3, 4, 5, 6, 1. We're missing a 1. Where does the 1 go? Well, you need to be a 1. You need to be a 2. Now you can't be a 3, and you can't be a 2. But we're missing a 1, so what's going to happen is we're going to have 8, 9, and 1. 8, 9, and 1, and 1. And also you can't be an 8. But you're allowed to be a 1, so you could have 1 and 9. Like that. This is all good. If you guys are 1 and 2, this means you're not allowed to be a 2. I wonder how long that's been there. You need to be a 4. You need to be a 2. We've learned about that. And now what can we do with the remainder of the column? I don't think that's going to be super helpful. Maybe we should do that and we should figure out the row after the fact. So 1, 2, we're missing a 3. 3 can't go in the middle. We've got a 4, we've got a 5, we've got a 6, but we don't have a 7 and 8. So 7 and 8 are the missing numbers. You're not allowed to be a 7 and you are not allowed to be a 3. Now in this row, we're missing 3 numbers. I bet those 3 numbers are 3, 7, and 8. 3, 7, and 8. You're not allowed to be a 3 or a 7. You must be an 8, and now neither of you are allowed to be 8s. So the 3 and the 7 go here. We have a 7, 8, something like that. But now you're not allowed to be an 8, so where does the 8 need to go in this region? There's only one spot. It's this 8. And now we've got 1 and 9. Why, by the way, is this not allowed to be an 8? I guess it's because of this one. So you're a 9 now, which means you're a 1, which means you're an 8. By the way, you need to be a 2. You need to be a 1. Now you need to be a 9. Now you're a 2. Stuff like this. All right, lots of progress. But we have to finish it out up here. All right, so we can't have an 8. These need to be 4 consecutive digits, but we can't have an 8 on them, which means we can't have a 9. We also can't have a 7, 6, or 5, which means I think these numbers need to be 1, 2, 3, and 4. And I bet there aren't a lot of options for what goes where. You need to be a 4 so that you can be a 3. You can be a 2, and you can be a 1. And now I guess you need to be a 7 is what I meant to type in. And you need to be a 3, which is what I meant to type in. You need to be like that. Groovy. Now, if you two are going to be 5 and 6, that means you need to be a 4. By the way, you now need to be a 6. And now you need to be a 5. And now you need to be a 3. You need to be a 6. Oh, we got some confetti. What are we missing in this column? Let's not screw this up at the end. We've got a 1, 2, 3, 4, 5, 6, 7, 8. We are missing our 9. And then the last thing, 1, 2, 3, 4. I guess the consecutive lines make it easy. 5, we're missing a 6. And that was the puzzle. Yay, congrats. You solved the puzzle, the solution is correct, and we did it in 37 minutes and 20 seconds. So I liked this puzzle. This was called Triangles by Riffclown, and I had fun playing it. If you got this far in the video, thank you for watching, and I hope to do more puzzles with you soon. This was Triangle by Riffclown, and I'll post a link down below where you can play it. Thank you for watching. Have a good rest of your evening.